So, quiz. Oh, have to do my favorite student. There's going to be a question something like number 1. And here's what I mean. I'm going to give you a ramp, but rather than just say, find the acceleration, I'm going to ask you to do something with the acceleration. I'm going to ask you to find a v final, or a d, or a t, or a vi. Okay? Or I'll give you a t, a vi, blah, blah, and you can find the acceleration, and then I'll ask you to work your way back to the ramp and find a mu, a coefficient of friction. There was the skier question later on in the quiz, did that. Either of those, as far as I'm concerned, are fair game. There's going to be one of those on your test. So this wants me to find time. So if I was doing this, I would go, okay. And I would notice from rest. So I would say VI is 0. And it looks like there's a D of 4.8. It does say down the slope. Should I let that be negative? I think I'm going to I'll deal with that after. Because I know time is positive. So I'll just make sure I get a positive answer. I would say, you know what? If I knew A, I could find time. I would end up going D equals AT squared over 2. D equals a half AT squared. What happened to the VIT? 0. And so I'll say, okay, T is going to be 2 times D over A square root. You know what? I want everything to be positive. So I'll just, when I plug my values here, let D be positive and A be positive. In fact, I think I'm going to let that be positive. And that'll make my math easier as well. So now I know where I'm going. Now let's find the acceleration. This is a job for a free body diagram. So I'm going to go like this. mg. Just want to caution, as I've been helping some of you, I'm seeing some of you do stuff like this. When you break mg into its components, I'm seeing you're setting yourself up for some ugly triangles. Be a bit meticulous. When I'm calling this perpendicular, what I'm really saying is there should be a right angle between your perpendicular component and the ramp. Because the other thing I'm seeing is some of you are doing kind of a sloppy this, and then when you do the normal force, you're like that. Well, no, the normal force is also going to be dead perpendicular to the ramp, and I think that'll help you find stuff easier. So just a little note, and absolutely be putting arrows on the ends of your vectors. If you're not, you're setting yourself up for some silliness. Anyways, end of rant. mg perpendicular, mg parallel, color, 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 color. That's the normal force. Which way is this sliding? Down the slope. So which way is friction? Up the slope. Technically, this friction arrow should be shorter than mg parallel. I would only take marks off if I asked you to draw a free body diagram on your test. I will be somewhere 4 marks on your test asking you to draw a free body diagram where you have to pay attention to your arrow lengths. Somewhere. Meanwhile, who's winning? Don't say mg. Who's winning? mg parallel. Who's losing? Friction equals. So I would give you 1 mark if I saw this. By the way, what if instead of sliding down the ramp, what if it was sliding up the ramp? Which way would friction be pointing? And then I wouldn't have winner minus loser. I'd actually have winner plus winner. They'd both be winning because it'd be slowing down. No loser, like elementary school sports day, right? Okay. Now, meticulously, this is going to be mg sine theta minus mu times the normal force equals ma. I don't know the normal force. Oh, but look. mg sine theta minus mu mg cos theta equals ma. Is there an m in everything, Noah? Turns out the m cancels. Now, if you didn't, that's fine. You'll still get the same answer, but there is an m in everything. Is there a g in everything this time? No, so gravity still has a role. But it's kind of nice because normally I would say, how do I get the a by itself divided by m? But since the m canceled, yay, the a is by itself already. A is going to be 9.8. What was theta? 53. Sine 53 minus what's mu? I don't know what's mu with you. 0.44. 9.8 cos 53. Bit of a built-in error check. If this was dead vertical, what's the maximum A could be? Pretty sure it's going to be less than 9.8. Uh, 9.8 sine 53 minus 0.44 cos 53. Anybody see the subtle mistake that I did? See it? It's amazing how often that happens because your brain is checked off. I typed in 9.8. I got to do two of them in this case, okay? Did you all get an acceleration of 5.2316, blah, blah, 5.23? I'll carry this on my calculator. So 5.23 meters per second squared. Just so I can get all this on one screen, Mr. Dewick, I'm going to go like this. Hey, fancy schmancy. So time is going to be the square root of 2 times, what was D? 4 point something, 4.8 meters. Divided by, I'll write 5.23, but I'll use my answer button. Uh, 2 times 4.8 divided by answer button. Square root of that. Do you get 1.35? I would take 1.36 because that, depending if you round it off, but 1.35 seconds. If you got that, how many marks did I make this worth? On a test, I would make this worth 7. For 4 marks, really for 4 marks, Dewick? 1, 2, 3, 4, okay. I would probably go something like this. Half mark if I saw that line. Half mark if I saw that line. Half mark for the numbers. And then a half mark for the answers. Then I would probably go half mark if I saw that. Half mark if you got the t by itself. Half mark for the numbers. Half mark for the answers. What that does mean, Allie, is if you got the wrong acceleration, but you went 2 times 4.8 divided by your acceleration, square root, I would give you 2 out of 4 at least. You get some marks. Okay. 1, 2, 3, 4, 5, 6, 7. Yeah, there's like 9 or 10 lines. This is most of my written questions on your tests will be worth 7 marks because that's how they used to do it on the old provincial, and that's kind of the system I developed. Lets me give out lots of part marks. By the way, have you noticed in Physics 11, I would never have given you this big a multi-step question, but I'm kind of hoping you've made the adjustment, Nick, and you're realizing, yeah, I can do an 8 or 9 step question. Just go meticulous and I'm good to go. Physics 12. There is going to be a missing mass question on your test, like number 2. Either I'll give you the tension, find the acceleration, and use that to find the missing mass, or I'll give you the acceleration, use that to find tension, use that to find missing mass. What did I give you here? Oh, I gave you the tension here. Okay, so find the magnitude of the acceleration. I might not walk you through the step A and step B on the test. I might just say, find M1 and expect you to clue in. I'm not going to look at both, because if I look at both, I'm going to have more than one. By the way, the reason you can't go winner minus loser equals M all A is in that equation, you'll be missing both M1 and A. You'll have 2 unknowns in one equation. Doesn't work. So we're going to look at the mass that we do know. This is a job for a free body diagram. They told me mass 2 is accelerating downwards, and they told me mass 2 is 5.9. So this is the mass that I know. So if I write an equation just for that mass, it's going to be M2G minus tension equals M2A. How do I know that tension wasn't winning? I have to, because M2G is accelerating. I do have to tell you what the direction of the acceleration is. Okay? If I don't do that, you can't solve this. They want me to get the A by itself. A is going to be M2G minus tension over M2. A is going to be M2 5.9, G 9.8 minus tension 35.4 all over 5.9. There is a built-in error check for this one. If I cut the rope, the biggest A can be is 9.8. So I'm already telling you the answer is less than 9.8. By the way, the reason I give you these built-in error checks, it's on the off chance that if you're taking physics next year, some of your tests are multiple choice. You can cross off some wrong answers right away sometimes, right? Tricks of the trade. And I do give you some multiple choice questions on your tests as well. So, y'all get next. Oh, 3.8 even. That's a fluke. Works out nice. If you got that right, 2 out of 2. Otherwise, I would probably give you a half mark if I saw that. I would give you a half mark for that, half mark for the numbers, and a half mark for the answer. Find M1. Okay, now I'm going to write a free body diagram and an equation for the mystery mass. So it's very similar. It's M1G tension, but in this case, what's winning? Tension. Tension minus M1G equals M1A. What am I trying to find? How many M1s do I have? How many would I prefer? Get into the same side. Tension is M1A plus M1G. How many M1s do I have, Noah? How many would I prefer? It'd be really cool. It would be really cool if there was a grade 9 mathematical operation that I could pull out of my back pocket and somehow turn this from 2 M1s into 1. There is. Who remembers? Yeah, GCF. So I can factor out a greatest common factor of M1, and I'll get A plus G. What's the bracket doing to the M1? Multiplying. So how do I move the bracket over? Divide. Tension is going to be, not tension, M1 is going to be tension divided by A plus G or G plus A. M1 is going to be, what was tension, Mr. Dewick? 35.4 divided by 3.8 plus 9.8. Y'all get 2.6? Yeah? Units, it's a mass. Units, it's kilograms. If you got that, 2 out of 2. Otherwise, I would probably go half mark for that, half mark for that, half mark if I saw that, and a half mark for the answer. And yeah, then I would, there is going to be a using principles of physics right to explain question on your test. Okay? I'll talk about it when I hand the test out, but probably for that one, the easiest, not the shortest, not the best, but the easiest way to answer it would probably be to make up some numbers and crunch some numbers and show that what you think the conclusion is accurate just by looking at your answers. Although the best way would be to do it algebraically. What about for this one? Student of mass, big M, places a bathroom scale on a skateboard. Normal force, I'm thinking right away when I see bathroom scale. Then rolls forward on level ground while standing on the scale. What will the scale read? I think if everything's flat, even if you're moving forwards, your scale is still going to read M. Okay. Now it rolls down a ramp, which is inclined at an angle theta. what will the scale read? More than m, less than m, or m? What do you think? What'd you pick here? Allie, what'd you go with? I agree. 1 mark. Convince me. And I'm going to be pretty lenient here. So, Allie, did you give me a good argument? What'd you say? Did you write something there for where it says using part C? Oh, you didn't? Oh, okay. Sorry. I was impressed for a second there because you were correct on B. Okay. McKenna, did you write an answer? Something there?
Well, actually, I wrote a different answer because I thought, like, mass, about the scale would read mass.
Reads normal force.
Yeah,
so here's the question. On the ramp, is the normal force bigger, smaller, or stays the same? I agree with you. How might I handle this? Maybe a free body diagram?
Yeah.
Okay. I drew a ramp. I should draw better than that. Why don't I line it up with the lines, Mr. Duke? I can't draw. Well, okay, I see some of you glaring at me. Fine. Skateboard. Person. I mean, I'm just going to represent with a dot anyway. So here's the person. What are the forces acting on him? Get the obvious one. Yep. Okay. If you started to draw a free body diagram, I would smile. We would say, here's probably how I would answer this. I would say something like, scale measures. What does a scale measure? Somewhere I would probably look for that as an argument. If you indicated that in any kind of a way, wrote it down or whatever. Then I would say to myself, self, more specific, perpendicular. You know the answer to this. Of course you do. Yeah. Okay. Now, what's your normal? That. In fact, in the first situation when they're just rolling on level ground, that's what the scale would be displaying. But all the scale does, by the way, then, is it divides that force by 9.8 to display kilograms. If it's an electric scale, it's doing that. If it's a mechanical scale, that's just how they've actually, unfortunately, I'm using the word scale twice. The scale on the dial is just calibrated so that they've just divided it by 9.8. Okay. So not the scale, but the scale on the. Running out of words now, not just letters in English. Okay. So cos theta. How's that help? Well, you could either, first of all, I would also accept the argument when theta is 0 degrees, normal force is mg. When theta is 90 degrees, what's the normal force when theta is 90 degrees? And so if the normal force goes from mg to 0, it's getting less. In fact, I think we used that argument once earlier on where we looked at the extreme values, and if you said something like that, I'd give you full marks. I'm going to go a little nerd on you. If you play around with your calculator, cosine of theta is always less than 1. Where theta is between 0 and 90 degrees. If you try any cosine value, cos, 75, is that a decimal less than 1? Cos 3, is that a decimal less than 1? Cos 89, is that a decimal less than 1? Cos 22, is that a decimal less than 1? Anytime you multiply something by less than 1, you get a smaller answer. Okay? Therefore, let's try that again. Therefore, Fn will always be less than mg. Now, that's a purely algebraic answer, and I'm not expecting you all to come up with that unless you've done pre-calc 12, probably last year, because I don't think if you did pre-calc 12 in first quarter, I don't know if Mr. Gerard got to the full trig section. Who did pre-calc 12 first quarter? Did he get to the full sine and cosine graphs that look like this? Did you see these? Say no. I'm not sure. Okay. So here's what I want you to look at. First of all, if you picked less than m, 1 mark, and if you feel that your answer involved a free body diagram and a good explanation, you can either give yourself 2 out of 2, or you can check with me after and I'll critique it for you. Okay? Yeah.
Is it always less than m if that's the case? Because if, like, for example, if you were to have, like, say the mass of the skateboarder is like 45 kilograms, and then you were to multiply that by 9.8.
Okay. By the way, first I would say use 50 or use 100 and do yourself a fave, but you went with 45. I'm okay with that, but I would just never pick 45 because only 5 and 3 and 9 go into 45. 48 or 50 or 10 but anyways, so if you had a mass of 45 kilograms, that's your normal force. Okay?
And let's say that, like, it was like 25 degrees.
Good. 441 cos 25. Definitely less than.
Oh, I see. Okay, so it's not just like the mass, it's an mg that it has.
It's the normal force,
Okay.
which is not even the mg. It's how hard the ground is pushing up. Okay? And by the way, then if I divide by 9.8, the scale wouldn't be reading 45 kilograms. The scale would be reading 40.8 kilograms.
Okay, that makes sense. I'm really confused because I had
Yep.
like 399. I'm like, that's definitely bigger.
Then the mass, but not bigger than the normal force. The normal force, which is what a scale measures. Good. Okay? Excellent. There's going to be a question like number 4 on your test. And what I mean by that, there's going to be an Atwood machine, see the pulley, with a ramp. So instead of just hanging vertically, which was way easier, physics 11, ramp, physics 12. So one of the challenges is going to be figuring out which way it's going to slide. First of all, any suggestions on what this might be a good job for? You don't say. M1G. I usually put M1 on the left-hand side. I usually put M1 on the left-hand side. I usually put M1 on the left-hand side, kind of in the same order that I read, and that way it just kind of makes sense and all of our diagrams look the same. And I always make sure I label the masses with numbers when there's more than one mass. Not that I'm singling anyone out. Tension. M2G. D. Here would be M2G perpendicular. There would be M2G parallel. Color. Is there friction in this question? Oh, no friction. Okay. Oh. Tension. Who's winning? Well, the tug of war is between those two. Yeah? So here's what I would do to figure out who's winning. I would just quickly get my calculator out and I would go M1G. Yeah, am I missing something? Oh. You're correct, although I'm not going to need it for this question, and so my brain sloppily ignored that. I'm going to need it for part B when I bring in friction. Thank you, though. Yes, I owe you a candy. By the way, is there a normal force on M1? No, not on a surface. Remember last year when I first introduced normal force to kids, they go normal force loopy, they start seeing it everywhere, and so, oh, it's hanging, there's a normal force. Not if it's not on a surface. Good. M1G is 11 times 9.8. And then M2G 10.5 times 9.8 sine 58. 107.8 is bigger than 87.2. This whole thing is accelerating this way. Now I've got my direction. Who's winning? M1G. And then minus tension, plus tension, minus M2G parallel equals M all A. I haven't done this since before Christmas. I've missed this. Oh. Yeah, well, no, we're not. I didn't ask you to find the tension yet, I don't think. I probably did in part B. I hope I did in part B. Okay. So for now, tension cancels, though you're right. A is going to be M1G minus M2G sine all over M1 plus M2. It's going to be M1, 11, G, 9.8, minus M2, 10.5, 9.8, sine 58, all divided by 11 plus 10.5. Boy, I didn't give you much room here. I'm writing too big. Okay. A is going to be, it's a fraction, brackets around the top. 11 times 9.8 minus 10.5 times 9.8 times sine 58 divided by brackets around the bottom. 11 plus 10.5. Close off the bottom. That's a typo, Mr. Duick. I caught it as I hit enter. By the way, I would have also caught it because I got a negative acceleration. I would have freaked here. Something's wrong. You get 0.955? Barely accelerating, which actually makes sense because the masses are almost identical. This is a really steep hill, nearly vertical. This is almost an Atwood machine in equilibrium, not quite. I did that on purpose so that it was tough for you to figure out which way was the winner. 0.955. Meters per second squared. Did I round off properly? Yes, I did. 2 marks for that. I would give you a half mark for this line, a half mark for that line for doing the trig, half mark for the numbers, and a half mark for the answer. Find the tension. Which mass would I probably use to find the tension? Yeah. Even though technically M2 tension's a winner, it's just much easier to work with M1. So I would go M1G minus tension equals M1A, and then just do the swappy dance. M1G minus M1A equals tension. Way easier. Tension is going to be M1, 11, G, 9.8, minus 11 times 0.955. Answer button. Do you get 97.3? Newtons. 2 out of 2 for that. Otherwise, again, half mark for the first line, half mark for that line, half mark for the numbers, and a half mark for the answer. Ooh, nice follow-up question. What would the minimum coefficient of friction need to be between M2 and the ramp in order to hold the entire system stationary? I guess that means A is 0, which is kind of nice. Well, which way will I add friction to my free body diagram? Up the ramp or down the ramp? Because which way is M2 sliding? Up the ramp, so friction's going to be acting down the ramp. Okay. By the way, the fact that it's barely accelerating, I'm betting mu's not going to be very big because this is almost at rest. We just only need a little bit of friction. I'll bet you. I don't know. I could be wrong. So friction that way, yes? So now it's going to be who's winning? It's a tie technically because we're at rest. You could sort of think everything down the ramp equals everything up the ramp. This is a complicated enough one that I would still say I'll pretend M1G is winning. I'll write my equation. It's going to look like this. M1G minus tension plus tension minus M2G parallel minus friction. But that equals, why does it equal 0? A is 0. I'd probably do it that way rather than try and get in one step. Tension still cancels. What's this question asking me to find? Where is mu hidden inside of what? Let's get friction by itself. I think I would just plus friction over. And I'll get m1g minus m2g, 2 lines is sine, equals friction. Although, you know what? Equals mu times the normal force. How would I get the mu by itself? I don't know the normal force. Oh, but look. I think divide by m2g perpendicular cos. Yeah? Okay. I'm running out of room here, so let's see if I can kind of write small. So my first thought would be to go mu equals m1g minus m2g sine theta all over m2g cos theta. And now I would plug in the numbers. What's mu? What was M1? 11, 9.8 minus 10.5, 9.8 sine, I forgot what theta was, 58, divided by 10.5 times 9.8 cos 58. Oh, the g's would have canceled. I didn't even notice that, but turns out there is a g in everything. Did you notice that, Wes? So you canceled out the g's? Well, clever you. Doesn't matter, because I'll still get the same answer, but I'm lazy. 11 minus 10.5 sine 58 divided by bracket 10.5 cos 58. I think that's right. You get 0.377? People nodding? What are the units for mu for a coefficient of friction? Oh, nothing. There you go. So 2 out of 2 for that probably would give you half mark for that, half mark for that, half mark for that, and a half mark for the answer. Oh yeah, here's what I said earlier. I said there's going to be a ramp, William, on your test. In this case, though, instead of saying use the acceleration to find a time or something like that, here I'm giving you enough information to find the acceleration, go to the ramp, and find the coefficient of friction. I'm pretty sure that's going to be my approach. Because I would say this is a job for a free body diagram. I would go, okay, mg perp. I can't remember who I was talking to yesterday. Somebody, I said to them, I'm hoping these are starting to get kind of repetitive. Like you're categorizing them. Oh, I've seen this before. Just a slight variation. And that was kind of my goal with this, okay? Normal force, and I guess friction would be up the ramp. And so I would start out by going mg parallel minus friction equals ma. mg parallel minus mu times the normal force equals ma. I don't know the normal force. Oh, sorry. Disappointed some of you. Color. I don't know the normal force. Oh, but look. So it's going to be mg parallel minus mu mg perpendicular equals ma. Did I tell you the mass of the skier? Yeah. Did I need to? Turns out, no. Two lines is sine. Equals A. I want to get the mu by itself. I could have plus the friction over on this line already because I know that's where the mu is hidden. I'm going to plus the friction over here. In fact, I'm going to do a swappy dance. I'm going to minus the a to the left. I'm going to plus I'm going to plus mu g cos to the right. I'll get g sine theta minus a equals mu g cos theta. Final step. How would I get the g by itself? So how would I get the mu by itself? Mu is going to be g sine theta minus a all over g cos theta. Problem. I don't know the acceleration. Or do I? Josh, I can figure it out. So I'd probably draw a little line like this, and I would say, okay, I need to fill in the acceleration. What have they told me? VI is 0, I saw from rest. VF is 20, and I saw a time of 8. It's like, oh, physics 11. Yeah. A equals VF minus VI over T. It's going to be 20 minus 0 over 8. I think I do that in my head. It's going to be 20 over 8, which is 10 over 4, which is 5 over 2. Is A 2.5? So, my final answer, mu is going to be G, 9.8. Sine, was theta 15 degrees? 14 degrees? 16 degrees. Minus 2.5. All over 9.8 cos 16 degrees. Cool. Any typos? That looks okay. Do you get 0.021? Which is small. Oh, no. Are we skiing on snow? Should be small. I'm okay with that. Actually, yeah. Should be close to 0 because snow is slippery. So 0.021. You could add one more digit if you wanted to. 0.0214 if you wanted to go to 3 sig figs. But whatever. 4 out of 4 for that. By the way, I need to change these quizzes because this really should be worth 7 marks because look at all the steps, right? So how would I, if you got it right, 4 out of 4, otherwise, how would I give up part marks here? I would probably give you half mark if I saw that and a half mark for finding A. Then I would give you half mark. I would probably give you half mark if I saw that. Half mark if I saw that. Half mark for that. What am I at now? 1, 2, 3. Half mark for the numbers, and then a half mark for the answer. I like number 6, I like number 6, I like number... This is a lawnmower question. There's going to be a lawnmower question on your test. Either the mass will be accelerating or it will be at rest. If it's at rest, what's our acceleration as a number exactly? So in our winner minus loser, it's a tie, which makes things easier. In this case, it says not moving, so it's at rest. If it's moving, I'll have a clear winner, William, and a loser, and we'll do our usual. You know what this is a good job for? In fact, it wants me to draw a free body diagram here, okay? And I will ask you somewhere on your test to draw a free body diagram. Please, you can label the picture, but I won't mark the picture. I will mark what you put in the white space where I show you to draw a free body diagram. So here is my free body diagram. What are the forces acting on it? Get the obvious one. Okay? And then there is an applied force. How big is that? 140 newtons. There's a normal force. Is the normal force going to be bigger, smaller, or the same size as mg? Smaller. Okay, so if your arrow for the normal force is the same size as mg, I would take a half off. What am I missing? Well, you could arc components. By the way, if you're going to put components on a free body diagram, make them dotted lines, because technically the 140, that's the force. Okay, so what did we call that one? Fx and Fy. You can call them parallel and perpendicular. I won't take marks off, but usually we went with horizontal and vertical on a flat surface. What am I missing? Why would that be wrong? And why would that be wrong? How long does friction need to be exactly if we're at rest? What? Thank you. That's a concept that kids have struggled with. I'm impressed. I heard almost all of you murmur, same size as Fx. Good. So, how many blue lines did I draw? How many marks is it worth? Half mark for each blue line. I would take a half mark off if this blue line was not shorter than mg, and I would take a half mark off if Fx, sorry, I put an Fx there. That was silly of me. If friction wasn't the same size as Fx. Eyeball it as long as they're close. Okay? Yeah. And you know, since I did such a good free body diagram, I could label my picture up there, but I think I'll just continue to use this now for the rest of the question, because it says, calculate the force of friction on the bale. My first thought would be to go like this. Why can't I go mu times the normal force? Be obvious. Why can't I go mu times the normal force? No mu. Jeez. How can they figure out how big friction is? Oh, but look. I know another force the same size as friction from my free body diagram. Which one? That's how I'm going to do it. I'm going to say this. Friction equals Fx. And so I'm going to figure out how big Fx is. Color. Fx, opposite, adjacent, or hypotenuse. Is it cosine? Is Fy sine and Fx of cosinus? Well, we'll take that. Okay, so friction is going to be the applied force, the 140, cos theta, if I generalize it. So it's going to be 140 cosine 28. You'll get 123.6. I'll write 124, but I'm going to, I'm going to write 123.613, and then I'll put equals 124, because I may need this. 124 newtons. If you got that 2 out of 2, I would give you half mark if I saw that, but that's the aha moment right there. If you see that, you're probably in good shape. Half mark for that. Half mark for the numbers. And a half mark for the answer. Oh, this is a better written question. I made this one worth 7 marks. Grand total. Good. C wants me to find the normal force. Is this a lawnmower question, Aiden? Normal force is not mg. But Aiden, is this bale sinking into the ground like quicksand? Is it flying through like Superman? That means everything down has to equal everything. What is everything down? Look at my free body diagram. Change colors, Mr. Duick. mg. What's everything up? There are 2 arrows pointing up. Okay. I'm impressed because this is a question kids struggle with. So why are you putting it on the test? Because you struggle with it, and it's a good. If you understand this, you've wrapped your brain around what we're getting at with Newton's laws. What are they asking me to find, Aiden? In part C? I'll get the Fn by itself. How I'll move the Fy over. Yeah, okay. So I'll get this. The normal force is mg minus Fy. Fy. Really? So the normal force is going to be mg minus 140 sine 28. What was m, Mr. Dewick? I don't even know. 55? G minus 140 sine 28. 55, geez, 55 times 9.8 minus 140 sine 28. 473.273. I'll carry some extra sig figs and then I'll round off. 473.274. 473.274. So 473 newtons. How many of you got that? I'm impressed. This is tough. Half mark. Half mark. Half mark. Half mark. My writing just gets messier all the time. Nick, what do you want me to find? There, I think the first thing that I would write is, well, friction equals mu times the normal force. I guess mu equals friction divided by the normal force. Nick, what did I find in part B? What did I find in part C? Oh! So I will say this. If you got B or C wrong, but you, for part D, divided your answer from, took your answer from B and divided it by your answer from C, I would give you 1 mark for part D. Anyways, it's going to be 123.613. If you used 124, that's okay. 473.274. 123.613 divided by 473.274. 0.2611 if you went 123 divided by 473. Sorry, 124 divided by 473. 0.261, 0.262. And mu, no units. Is that all right? Whew, that had some teeth. Can you give yourself a lovely score on this massive quiz? Basically, this was pretty close to the written section of your test. Okay? Out of 29, please. Any lawyering with me, or if you wanted me to look at your answer from the Using Principles of Physics, right to explain. Ultimate review, this big document here. Okay. Number 1 is fair game. That one I like. Number 2, I would almost say is too easy. I'm going to ask you probably to find a coefficient of friction, but not on level ground. 3 is good. Find a missing mass. I'm just saying that in terms of level of difficulty, here's what I would say to you. If you can kind of glance at to visualize the free body diagram and do it on your calculator, go ahead. But if you skip it, I won't freak out in this case. Okay, so 3 is good. I'm not going to give you a 3-block system. I have in some years, but it's just extra. 6 I like. 6 I like. So definitely do 6. So I guess I can kind of circle these. 1 is good because it's good conceptual. 3 is good. 6 I really like. Here's a missing mass question, number 7. This is actually, I think, a little bit easier. I have a feeling when you try and get the M by itself, there's only going to be one M. You won't need to GCF. You'll just be able to get it by itself. I'm just doing it in my head quickly, and I think. 10, lawnmower. 12, missing mass is good. 13, lawnmower. 14, there. This is a good example of where I might ask you to find a coefficient of friction. It's on a ramp. So 14 is good. 15 is just good conceptual, understanding free body diagrams. Another missing mass, 16. 17 is good. '18 is good because the normal force isn't mg, and you're noticing this year more and more the normal force is not mg. '19's too easy. You can skip 20. 21 is good. '23 is good. 24 is good. 25 is a good conceptual question. I'll skip 26. That's really physics 11. 28 is just good conceptual again, free body I'm going to ask you to draw a free body diagram, so I may as well give you some practice just kind of thinking about them. 32 is good. 34 is good. This is going to seem weird, but even though 36 is technically a scholarship question, I don't know why that was a scholarship question. I think that's doable. That's a ramp with an Atwood machine. We did one like that actually on the quiz today. And only instead of the ramp going uphill, the ramp went downhill, but it was still one mass hanging over a cliff and another mass on a ramp. Okay. So that's fair game. I think 38 is fair game, even though it's a scholarship question. Oh yeah, definitely. Ow! Actually, it's fairly easy. What's the two-word phrase that makes this question way easier? Can you see it? Constant speed. So what's A? So what min or minus equals 0, which is going to make it way easier to get stuff by itself. Yeah. So I think that's a fair game question. Yeah, 39. We did one just like that on the quiz. I don't know why these ones were considered scholarship. It's an Atwood machine with a ramp. Meh. So find the acceleration, find tension. But not 40. Okay. Any questions from the homework you'd like me to go over? You think you lost yours? The 30-page review with paper that I photocopied for you, that one?
Yeah, the only one I have is the one from...
The kinematics one?
Yeah.
Well, you should have one from last lesson.
Yeah, I have the new one.
Oh, you got a new one? Okay.